Hello, marvelous Algebra 1 students, and welcome to this lesson on solving equations. This lesson is really designed to be watched after you've gone through the first 5 lessons of this unit, all the way through proportions. If you haven't done those 5 lessons, those ones are going to go more in depth. So there's probably 2 reasons you're at this lesson. Reason number 1 is because you just want a better idea of how to solve all types of equations. You've watched the first 5 videos, you still need more practice. Well, this is going to get down to the nitty-gritty of just showing every type of equation you might be asked to solve in Algebra 1. The second reason you're here is because you already took your test and maybe you didn't do super well and you want to do a retake. And in order to do a retake, you have to complete your remediation, your relearning, and that's what this video is designed to do. It's designed to reteach you all of your Algebra 1 equations. Now, you might already know how to do some of the basics on here, so we would definitely encourage you to go through and try to start solving each of these. And then if you get stuck, just skim the video to that part. So maybe solve the section on one-step equations, and then watch the video at 2 times speed to make sure you're getting the answers right. If you find a section where you're either getting stuck or you're not getting the answers right anymore, then watch it from the beginning to get some good insights. But otherwise, you're going to be watching a pretty long video, and so it's definitely worth pausing, trying it on your own, and then listening to the video or skipping through the parts where you get stuck. So let's go ahead and jump into it. We are, of course, solving equations, and we should know that an equation is solved, right? There's the extra over there. Yeah, perfect. We'll do this. Is solved in algebra when you finish removing all the numbers that are operating on x. And that means you look at one side of an equal sign, like over here, here's the left side of the equal sign that has the x. We can ignore the right side for now because we're only focused on the side with x. And we can see that this first equation is not solved. And it's not solved because there's still a number attached to x. What number is attached to x? Well, we should know that if we think through SADMAP, which we're going to use a bunch in this video, this tells us how numbers are attached to x and how to undo them. So I would look right at this 3 that's next to the x, and there's something separating the 3 and the x. The thing that's separating the 3 and the x is subtraction. So we say this equation is not solved because 3 is subtracting from x. All right, but if we look at this second one, it says x equals 12. Well, this equation is solved. We are done. We don't need to do anything more because there's no numbers attached to x. Now, you might say, well, wait, there's a 1 attached because there is always an invisible 1 that's multiplying. But if there's just an invisible 1 multiplying or even an invisible 0 adding, that doesn't change our answer, right? This is solved because no number is attached to x besides 1 or 0. Okay, let's look at that third one. Is x isolated here, right? When we say x is isolated, we mean if you look at the side that has x, the right side, there's nothing else with it. And yeah, x is completely isolated. So this one is solved because x is isolated, or whatever reason you used for the second one. And then looking at the last one, is x isolated here? Well, hopefully you've realized it's not isolated because there's this minus. Now, you might have the question often in algebra, wait, is that a minus or a negative? And strangely, they are both the same thing and different things. And it really depends on your perspective because I know that's a confusing statement. So at this point, I would probably think of this as a negative sign. I would read this as negative x equals 5. But a negative always has to be attached to a number. And so what number is here? Well, we can, just like on our last one, put an invisible 1. Now, you might think that this 1 is attached by subtraction, but the number is always attached by the sign that is between the number and x. And so what sign is between the 1 and the x? Well, if there's no sign written there, we know that's always multiplication. So the reason that x is not isolated here, if we go back to SADMAP again, is that this negative 1, we'll box it like so, is multiplying by x, right? If it were subtracting from x, it would actually say x minus a number, right? It'd be in between the x and the number. All right, well, that's enough for our introduction of how do we know if an equation is solved or not. Let's actually get into solving these equations. It's important to realize when we solve an equation that you, a lot of times, will be able to look at the equation and know the answer, right? And you probably should use that strategy on some easier equations. For example, on this first equation, it says, what plus 5 is 8? And I would really hope that you know that 3 plus 5 is 8, and you can skip right to that answer. But for the purpose of this activity, because we're starting with easy basic equations, we want to actually go through the process of undoing SADMAP, of working backwards, of isolating x, even if you think it's an easy equation to solve. And again, hopefully it is. And then when you get to the answer, you should think in your head, is that right? Is the answer we got plus 5 equal to 8? Yeah, 3 plus 5 is 8. Now let's take a look at the work here. You're going to be asked to do two things on pretty much every problem for this video. The first thing we're going to have to do is we're going to have to figure out what numbers are on the same side of the equal sign as x. And in this case, that's a 5, isn't it? And how is that number attached to x? And remember, a number is attached by the sign that's between the x and the number. So the sign that's here is a positive, which means 5 is adding to x. Well, now that we've identified how a number is attached to x, we have to remember how to undo it, or how to isolate the variable. And luckily with SADMAP, the way we undo it is the letter that's right next to what is attaching the number to x. So what's right next to a in SADMAP? Well, there's an s. So that tells us that we can take this x plus 5, and I'll group it in parentheses, and the 8, group it in parentheses, and then we undo the 5 with subtraction. Of course, we know in algebra what we do to one side, we do to the other. And then we also know that a number minus itself is 0. And I just put a big 0 there just so it cancels out. We can say 8 minus 5 is 3, which hopefully is not shocking to you, as we already went over why the answer is 3. Now, the other thing you might say is, whoa, crazy talking voice, how come you did this horizontally side to side? My teacher taught me a different way. And here's the way your teacher probably taught you, and it's a great method. I'll probably use it for a lot of this video. They probably said, and we're just going to go right here, if you have x plus 5 equals 8, then you would take the subtracting by 5 and write it underneath the number you're canceling out. And I think that's great. A nice advantage of this technique, this second way we're doing it, is it lets you line up your like terms. And so we can see 5 minus 5 is 0. We bring down the x. We always bring down the equal sign. That's a very common mistake I see people forget. And 8 minus 5 is 3. And great, we get the same answer. So hopefully your question is, well, how come if this combines your like terms so nicely, why did you use this method up above? And I use the method up above for two reasons. First, when we're doing our solutions, we post them electronically. This method is a lot easier to use to type things out. And the second reason is it actually saves space on your paper. See, we only used 1, 2 lines here, but over here we used 1, 2, 3 lines. And so it really doesn't matter which way you use. And I'll probably use both. I bet I'll use this one a little bit more often, but if I find myself short on space or just to remind you, I might use the other. But they both work. All right, so at this point, you really should pause this video and try some problems. Now, if you get stuck on the, what does the rewrite mean, or am I doing it right, skim to that part and make sure the answers are matching. And if you're not, unpause the video and take a watch. So why don't you work through these next 5 problems, unpausing whenever you need. Ready, set, go. All right, let's take a look at problem 2 here. Problem 2 has the x on the right side. We have a 3 over here, and the sign in between the x and the 3 is a minus, right? So we know that this is subtraction. All right, how are we going to undo that subtraction? Well, luckily we have addition right next to it. So I have negative 2 equals x minus 3, and I know that I need to add 3 to one side. Don't add 3 to the x. That's adding 3 to the same side. We always add to the opposite side of the equal sign. I think it's important to bring your equal sign down pretty quickly so you remember where that barrier is between the two sides. Okay. We end up with a 1 and an x. And I think we're set. X equals 1 or 1 equals x. They do mean the same thing. And if we check it, if we think is 1, if you start at positive 1, and then you subtract 3, is 1 minus 3 equal to negative 2? You could check it on your calculator, you could check it with a number line, or you could do some mental math. Yeah, 1 minus 3 is negative 2. All right, let's look at that third one. Now, our third one has this weird rewrite. And I always think it's nice to go through and rewrite a side of the equal sign if x isn't first by moving x first. So the rewrite here, I'm going to keep the 5, keep the equals, though you could switch the sides if you want, and then I'm going to move this positive x first. And you could put the positive if you want. The positive is attached to x. The sign to the left of a variable is always attached to the variable or the number. But I think we also know that at the beginning of an equation, we don't write the plus if it's positive. But I am going to take this 0.5 and put it at the end. But we can't just put 0.5 here, because if there's no sign between them, that means that these are multiplying. And I don't think these are multiplying, are they? We can clearly see that they're adding together. So if we move this positive 0.5, right, there's that invisible positive, we do need to put a plus 0.5. Okay, so we're going to go through and identify how the 0.5 is attached to x. Well, we have a 0.5. We already said it's attached by addition. So we need to undo addition with subtraction. All right, so we're going to subtract 0.5 from each side. Bring down our equal sign so we remember where that barrier is. Check to make sure that you've done the same thing on both sides of the equal sign. $5 minus 50 cents is $4.50, and it leaves us with x, or x equals 4.5. A quick check. If you do 0.5 plus 4.5, is that 5? Certainly is. Okay, 3 to go. Negative 2 plus x. Notice that on the left side of the equal sign, x is not first. I'd suggest a rewrite there. I'd take this positive x and put it first. And then this is where things get weird. What are we going to put second? Well, because this 2 has a minus in front, we actually read this as a negative 2, right? A minus always has to have numbers on each side. But as soon as I move the negative 2 down here, now there's going to be an x on the left side. And so now instead of reading this as a negative 2, we read it as a minus 2. And so this says x minus 2 equals 7. Can you mental math this? Can you tell me what minus 2 is 7? Yeah, it's going to be 9, I think, right? But let's double check it. So if I do x minus 2, and I keep my 7, I always put a little space here, we can identify that the 2 is attached by subtraction. And that's pretty tricky, right? You might have looked up here and said, oh, it's attached by addition. So I'm going to do the opposite of addition. I'll subtract 2. But if you subtract 2 from 7, 7 minus 2 is 5. You'll end up getting the wrong answer. Which is why it is really important, at least at the beginning, to move your x to the beginning of the equation. So if we're attached by subtraction, that means we need addition, like so. X minus 2 plus 2 becomes 0, and that leaves me with x equals 9, as we expected. Now, if you had subtracted 2, you would get 5. But you should check on your calculator. Negative 2 plus 5 on your calculator will get 3. And you were supposed to get 7. So you should have known that you got a wrong answer there. All right, let's try 2 more. 0 equals negative 3 plus x. Ooh, look at that suggestion of rewriting. Now, I didn't give you enough space to write the 0 over here. Maybe we can just try switching the sides. So I'll put the positive x first. And then this is a negative 3. But when we move it, it becomes a minus 3. Wait, we need an equal sign, though. So we have equals, and then what's on the other side? Oh, 0. So we actually rewrote this in 2 ways. We took the right side of the equation and put it on the left, totally allowed, and we moved the positive x first and the negative 3, making it a minus 3 second. All right, I didn't give you guys SADMAP here, and maybe you're becoming pretty confident and you don't need SADMAP, but others of you, it's a really nice strategy to help organize your work, right? It says, okay, what's attached to x? That's a 3. It's subtraction. We know to undo subtraction, we use addition. Bring down that equals. That'll let you make sure that you did something on both sides of the equal sign. That leaves us with x equals 3. And again, something like this shouldn't be too surprising. Negative 3 plus 3 is 0. All right, last but not least, negative 5 plus x. Once again, rewrite it. Let's put the positive x first, the negative 5 second, equal to negative 7. Okay, SADMAP, I bet you can do it without writing SADMAP here. We see a 5 is attached with subtraction, so you know you use. Very nice. Addition. Bring the equal sign down first. Make sure that you did the same thing on both sides. And we get x equals -2. Now, you could also have done this without moving the x, and it's probably important as you guys get more confident with this to see how we could move faster, right? If we had -5 plus x equals -7, we always want to look at the number that's attached to x and then check the sign to the left. And that's going to be the same thing as what's attaching it to the x. So as soon as I see a -5 here, I would know, oh, we are going to add 5 to each side. Right? And so that's just kind of that trick, making sure we do opposite signs of whatever number is attached. We still did the same thing up above. It's just a little bit easier with SADMAP to see that method the way I did it first instead of how I did it here, which is -2. Right? -5 plus -2, that is -7. Okay. Well, if you're feeling decently confident with these one-step equations, that's awesome. But if this section is still stumping you a bit, definitely find your teacher or a friend and ask them for some help. We can do many, many more one-step equation problems. But you should also notice something about the 6 problems we just did. Each of those problems only used the S and the A from SADMAP. We have like 4 other letters that we've neglected here, right? We just used S and A. So let's go ahead and focus on the D for division, M for multiplication part. We're not really going to do anything with E with exponents this semester at all, and parentheses are kind of a special case. We'll get there kind of at the end of this video. So let's try those same one-step equations, which means we're only doing one thing to each side, one line of work. And we'll start with 7. Now, 7 could be pretty intimidating because you're like, oh my gosh, a fraction? I don't know how to deal with that. But I think you do. Instead of thinking of this as a fraction, let's read this fraction line as it should be read. Instead of saying x over 2, let's use this fraction line to mean division. And it actually says x divided by 2 equals 5. Okay? And then we're going to go through and say, okay, well, x divided by 2, that means that 2 is attached by division. Okay? So, how do we undo division? We multiply. Now, one thing I see a lot of students do here is they say, oh, because this is a positive 2, I need to multiply by a -2. And that's not quite the case. When we were adding and subtracting up here, we made zeros every time. And the only way to make a 0 from a negative number is to use a positive. The only way to make 0 from a positive number is to use a negative. But when we're multiplying and dividing, we're not going to make zeros anymore. In fact, what we're trying to do here is we're trying to make ones. And think about how you would make 1 with multiplication and division, right? If I had something like 2 divided by what equals 1? Well, you would probably not say -2 because a positive divided by a negative is a negative. We need the same sign to turn into a 1. Now you might be thinking, why are we using a 1 here? Why did we change from a 0? Well, I'll show you that in just a second. So for now though, let's at least agree that if we're going to make 1, they need to have the same sign. So this says 2 times and divided by 2, and 2 divided by 2 makes 1. Now, you could keep the 1 here that's right next to x, and if it's right next to x, that means it's really multiplying, right? But 2 things to note. First, if you do something to one side, you have to do it to the other. And you might notice that I carefully put the times 2 by the x in the top of the fraction. We're not multiplying the 2 in the bottom of the fraction. That would become a 4, and that would make the fraction more complicated. And that's useful because when I multiply over here, I'm going to multiply by 2 next to 5. And I put the dot in a weird spot, and I'll move that in a second. But that's because 5 is also a fraction. It's 5 over 1. So when I multiply by 2, I want to make sure that I'm multiplying by the top of the fraction and not the bottom. So times 2 up here, times 2 by the 5. And what is 5 times 2? Oh yeah, that's 10. Now, I'd mentioned that you have this 1 in front of x, and you're like, what? That now x still isn't by itself. But we actually started this video by saying if there is a 1 next to x, we actually don't need to write it anymore. It's implied that if there's an x, there's always a 1. It means there is one x, and the value is 10. So we get x equals 10, right? Here's our final answer. And it makes sense if you think back to the problem. It was saying what divided by 2 is 5? 10 divided by 2 is 5. Easy enough. So a couple things to take away here. We undo division with multiplication. And with division and multiplication, we don't do the opposite sign. We do the same sign. If we see a positive 2, we use a positive 2. If we see over here, a negative 3, well, let's think about it. Okay. What are we going to multiply both sides if there is a negative 3 dividing to x? Well, we're going to multiply by a negative 3 because negative 3 divided by negative 3 is 1. And we now know we don't even need to write the 1. But don't forget, whatever you do to one side, you have to do to the other. So times negative 3 over here, which leaves us with x equals negative 6. A quick check. Negative 6 divided by negative 3. Negative divided by a negative is a positive. 6 divided by 3 is 2. Okay, now that we've gone through all that, why don't you guys go ahead and maybe try these last 4 problems here. Okay. And then if you ever get stuck, unpause. Otherwise, skim through, make sure the answers are right, and you're about halfway done. Ready, set, go. Nice. All right, let's take a look at 9 here. So it says negative 3x equals 12, and they asked how the negative 3 is attached to x. There's a little rewrite here, and you don't really need to rewrite this, but I think it's important for us just to remember what's in between the negative 3 and the x, because the letter of SADMAP that we're going to circle is all about the operator, the addition, subtraction, multiplication, the division that's between the number and x. So this is not subtraction. Subtraction is not between those two. What is hiding between if nothing is written? Well, that is always multiplication. So what that's telling us is that negative 3 here is multiplying by x. All right, well, now that we know that, now that we rewrote it with the multiplication symbol in between, how do we undo multiplication? Oh, that's division. Okay, so we're going to go through and divide each side. Bring down your equals for later. And what do we want to divide by? Students are like, wait, do I divide by the negative 3 or the 12? But think about your end goal. We want x by itself. So we need to remove the number that's attached to x, and that is your negative 3, right? And so we know with multiplication and division, we do the same sign. Whatever we do to one side, we do to the other. Anything divided by exactly itself makes 1, which we don't need to write. Positive divided by a negative is a negative. 12 divided by 3 is 4. So we end up with x equals negative 4. And a quick check, negative 3 times negative 4 is positive 12. All right, 3 of these to go. Negative 4 equals 2x. This says 4 is attached by, that's a typo, apologies, it should be a 2. Will be better next time I post this. So we have negative 4 equals 2x, and we ask ourselves, what's the operation between 2 and x? What's attaching them? If nothing's written, has to be multiplication. So let's undo the multiplication. Okay, and we know that's going to be division. Bring down that equals. But divided by what? Well, we need to remove the number on the same side as x. We divide by that 2. Do it on each side. These cancel. And we end up with x equals negative 2, or you can put the x on the left side, the negative 2 on the right. Here comes 11. Negative 2 equals negative 4x, and this one again has a small typo. It should be a negative here. Easy fix though. So how is the negative 4 attached to x? You might be tempted to say subtraction, but remember, we always need to look in between the number and the variable. And what's in between there? If nothing's written, that has to be multiplication. So negative 4 is multiplying. So let's undo multiplication with our division. These make a 1. Let's see. Oh, this is a weird one. 2 divided by 4. So we know a negative over a negative makes a positive, right? These guys will become a positive, nothing bad. But then we have to think top to bottom, 2 divided by 4. If you remember division, they're saying imagine you have $2 and you want to split that $2 evenly among 4 people. How much does each person get if you have $2 split among 4 people? And hopefully you're like, ooh, I know that one. That's 50 cents. And you're right. You actually could write this as 0.5 or 50 cents. You could even keep this fraction as it is, but let's make it positive, 2 over 4. And then you might even remember how to reduce that fraction. Isn't 2 over 4, if we divide by 2, the same as 1/2? All of these mean the same thing, and your teacher will let you know if they prefer a fraction over a decimal, if you have to reduce your fractions, but if you can get to any one of those, you're doing just fine. Okay, last one, negative 12 equals x. Or negative x equals 12. Reading. Well, that says rewrite, and there's this little blank here. Because what is attached to x? Is there just a negative attached to x? Okay. Well, you could read that as negative x. It's certainly not going to be minus x because there's no number over here. So if I write this as negative x equals 12, we need a number. And the number has to go in front of the x. Right? It's not going to go here, because that means a number minus x, and we know it is going to be a 1. So we need to kind of slip that 1 right in between the negative and the x. And then ask our question, how is negative 1 attached to x? Well, it's all about the operation that's in between the number and x, and in that case, that again has to be multiplication. So negative 1 is multiplying by x, which means we need to divide by negative 1. Okay? We bring down our equals. Negative by a negative is a positive. Positive by a negative is a negative. And we're set. What you'll start to realize is if you see negative x equals 12, the answer is just really going to move the negative to the other side, just like we saw over here. And that's a nice shortcut if you start to recognize this. All right, so a quick conclusion for our one-step equations, and then we'll jump into our two-step equations. When we undo addition or subtraction, you have to do the opposite sign. So if you see a plus 2, then that means that we are going to need a negative 2. However, if you're undoing multiplication or division, you have to use the same sign. My screen is jumping a bit, so I may pause this and come back into it. But yeah, multiplication and division, same sign. Addition and subtraction, opposite signs. Now that we have that, we're going to move into two-step equations. Now, two-step equations are just like one-step equations, but one-step equations only had one number on the same side as x. Two-step equations will have two numbers on the same side. So that means using SADMAP, you're going to have to circle 2 letters instead of 1, and you'll have to do 2 lines of work instead of 1 to get to your answer. It's also important to realize that SADMAP doesn't only tell you what to undo, it tells you the order you're supposed to undo them. Right? If we read top to bottom here, then that says we undo addition and subtraction before multiplication and division. And that's pretty important. Until you get more advanced, I'd suggest you follow those steps to the letter, because otherwise, if you do them out of order and you don't know some more advanced tricks, you'll start getting wrong answers. So why don't you try each of these? And again, if you need help from the beginning, you can let me keep talking. But if not, then you can go through and just blitz through these quickly, unpause the video, skim through, and make sure you got the answers right. Good luck, and we'll come back together shortly. All right, let's take a look at that first problem. 2x plus 3 equals negative 5. We're only going to focus on the side with x. We're going to ignore the negative 5 for actually a lot of this problem. And we'll focus on those 2 numbers there. I see a 3, and between the 3 and the x is addition, so we know it's attached by addition. And then I also see a 2, and between the 2 and the x, oh, that's multiplication. Okay, and we'll switch signs in case you don't have colors there. Perfect. All right, which one do we undo first? Do we divide by 2 or subtract by 3? If you look at SADMAP, though, it gives you a nice way. It says undo subtraction and addition first. It's at the top of the list. So we will subtract 3 from each side. Don't forget to bring down your equal sign. Really the first thing you should do. Otherwise, you'll lose track of where you are. Leaves us with 2. I'll put the times x in there. And negative 5 minus 3. And notice how I read that, right? If we're looking at this right here, the minus always separates two numbers, 5 minus 3. But this number out here doesn't have a number in front, so we read it as negative 5 minus 3. And that's tricky to get used to. So we end up with negative 8. But there is still a 2 that's multiplying by x. I'm going to rewrite it. I think most people would not, but it's nice for clarity. And so to undo multiplication, we use division. Notice with the 3's, one was positive, one's negative. That's because of addition and subtraction. But with multiplication or division, we use the same sign. So dividing by 2 on each side, bring down that equals. Anything divided by itself is 1, which we don't need to write. Negative divided by a positive is a negative, giving us our final answer. All right, second problem. We're getting the hang of it now. We have a 2, which is dividing, and a 3, notice in between the 3 and the x, which is subtracting. Let's undo subtraction first. Add 3, bring down that negative. Negative 3, positive 3 cancel, leaves us with x divided by 2 equals 8. And then we'll continue through here. To undo division, we multiply by 2 on each side. These guys cancel, leaves us with a 1, x equals 16, and we're set. It's a quick check too, right? 16 divided by 2 is 8. 8 minus 3 gets us to 5. Here's problem 3. 5 equals negative x plus 2. I'm going to rewrite that, I think. 5 equals, we know it's a negative, but there's no number there. I'll leave a little gap for the number, and then a plus 2. Well, what number is hiding, I guess? There's a 1 there. Let's think about SADMAP really quickly. I didn't give it to you because it's good practice for you to have to write. Really cements that in your brain. I see a negative 1. When we look in between the 1 and the x, there's nothing written there, so we know that that is multiplication. And I see a 2 at the end, which is adding. Okay. Let's undo addition first. We can subtract our 2 from each side, bring down that equal sign. This leaves us with 3 equals negative 1 times x. And undo multiplication. Keep the sign the same for multiplication. Anything divided by itself leaves us with 1. Bring down your equals. Positive divided by a negative is a negative. 3 equals x. Or x equals negative 3. Now on any of these problems, if you are struggling to keep the signs right, if you're not sure that positive divided by a negative, you should always try it first and then have your handy dandy calculator alongside you and double check it afterwards, right? Good to double check on your calculator just to make sure you're getting those signs right. All right, third one. 107 equals 3 minus x. Now this one is tricky. And the reason it's tricky, and I'll put SADMAP back over here on the side, is you might correctly say, oh, this is a minus. So 3 is attached to x with a minus. So I'm going to undo that with addition. And that's the issue. The issue here is that if you wanted to add 3, maybe I could even put it underneath the 3. What sign is hiding in front of this 3? Because the sign is always to the left of the number. And we should realize that there is a positive hiding here. If you do positive 3 plus 3 more, does that become 0? Hopefully you're saying, no, 3 plus 3 is 6. Well, if it's 6, then adding 3 isn't canceling out the 3 up above. So let's go back to my suggestion from the first page, and anytime you don't see x first, let's put that x, or in this case, the negative x first, and then this positive 3 at the end. But we don't just stick the 3 next to the x. That would mean that they're multiplying together. And they're certainly not multiplying. There's something in between. Because it's a positive 3, we can just put a plus, though. Okay? So negative x plus 3. But isn't there even a number hiding with that negative x? So I'm going to leave myself a little space here. And I'll put that number in as well. Right? We've done this several times now. We know it's a negative 1 that is multiplying. So I have a negative 1 multiplying and a 3 adding. Which do we undo first? Oh, that's right, we undo addition first. Okay? We'll use subtraction, and because I was running out of room, I left myself some space to work horizontally. I'm going to undo the adding 3 by subtracting 3 on each side, just making sure you're used to both methods. Those cancel. 107 minus 3 is 104, equals negative 1 times x. Last step, divide off the negative 1. Anything divided by itself is 1, which we don't need to write. A positive divided by a negative is a negative, and anything by 1 is itself. And so we end up with x equals negative 104. Fifth one. Ooh, now we're getting to some fractions, and this is where things get a little bit strange. We won't do too many fractions today, but it is nice to have this reminder. So we have 1/3 x minus 5. And what's weird about these fractions, and they kind of have their own rules here, and I'm going to give you a couple different ways to do it, is that whenever you see this 1/3 x minus 5, we can at least identify the minus 5, right? In fact, let's get rid of that subtraction first, just so we don't even have to worry about it. We're going to add 5 to each side. We know we have to bring down our equal sign. Those cancel, and it leaves us with 1/3 x equals 7 plus 5 is 12. Now, I'm going to give you a different way than you might have learned in class, and so that way you have another method. If you really want to go back to how we did these fractions before, go back to the first video in this playlist, and it'll give you how to use the reciprocal here. I'm going to give you that second method right now, and here's my second method. We know we can write any number or variable as a fraction, and the way we do it is we take that number or variable and put it over 1. So what I'm going to do is I'm going to rewrite this x as x over 1. And then we can remember how to multiply fractions. That's not bad. We multiply straight across. 1 times x is just 1x. 3 times 1 is 3. And I think we might remember any number times x, if it's just 1 times x, do we really need to write the 1? I think it's just x over 3. And in fact, 1/3 times x, a third of x, is the same thing as x divided by 3. And now we don't have that scary fraction out front. We're back to what we've been doing in the past. We have a 3 that is dividing, so we know we use multiplication. Times 3 times 3. Those 3's cancel, and it leaves us with x equals, let's see, 12 times 3. Oh, that's 36, isn't it? And we're set. Let's try that one more time with a negative and maybe a more complicated fraction. Same thing as before. We have a 1. We know it's adding. We'll undo it with subtraction first. Bring down that equals. Negative 5/3 x equals 25. Now, one thing to note, this negative 5/3 x, this negative out front just means the overall fraction is negative. I really like putting this negative on one of the two numbers instead of just leaving it in the middle, and that's going to become very important in our next unit when we graph. So I'm going to take this negative and move it up to the 5. Now, some of you might ask, well, wait, why are you putting it on the 5 and not the 3? And the answer is, it's personal preference. I always like to put the negative on the numerator. You can absolutely, if you want, put it on the denominator, whatever makes more sense to you. And maybe try both and see which one you like. But it can only go on one of them, because a fraction stays negative as long as one number is negative, not both. And then I'll use that same trick as before. Let's put x over 1. We multiply fractions straight across. Try to color coordinate this because it's a little bit trickier than last time, but not terrible. This gives us negative 5 times x divided by 3 times 1, which is 3. And now if we think through SADMAP, we already undid the addition way at the beginning, right? Now there are actually two numbers that are attached to x. We have a 3 that's attached by division, and we have a negative 5 that's attached by multiplication. Because multiplication and division are in the same line in SADMAP, you can actually undo either one first. So you could undo the negative 5 by dividing, or you could undo dividing by 3 with multiplying. And I'm going to suggest undoing division first. So I'm going to undo the dividing by 3 by multiplying both sides by 3. Okay? Anything divided by itself is 1, which we don't need to write. That leaves me with negative 5 times x, and 25 times 3, 3/4 is 75. Last but not least, I bet you know how to undo the negative 5 now because it's multiplying. Let's divide. Keep the sign the same. You might need a calculator for this one, or you can try it in your head, how many 5s till you hit 75, and I think you'll find it's 15. And a positive divided by a negative does give you a negative. Okay, at this point you have finished your two-step equations, and we're going to move a little bit quicker because we do still have 2 pages left, and I don't want this video to run for 5 class periods. So, if you're still stuck on two-step equations, chat with your teacher because we're not going to do anything crazy more complicated after this, but you need to be very confident with your 1 and 2-step equations. All right, let's move on to our third one. Solving equations with x on both sides. So if you look at a quick sample equation, we have one side with x and another side with x. And you really want to make sure that you don't just look into this and say, oh, 22 is adding, 5 is multiplying, because then you have another side. You're like, wait, 16 is adding, 7 is multiplying? Which one do I start with? There's so many things here. And so what eventually we want to do is we want to solve for x, whether the x is on the left side or the right side. But there's only x on one side, certainly not both. And so we want to kind of do the same thing with our equation here. We want to go through and make sure that there's only x's on one side of the equals, not both. Now, does it matter which side? Not at all. How do we make the x's go away? Well, we actually need to add or subtract those x's on each side. And we're going to do that to cancel out one of the x's. X's only completely vanish if they become 0. So we don't want to divide yet. Dividing will keep the x's. We want to cancel by making 0. So let's take a look. Let's look at these two, the 5x and the 7x, and let's just start with the 5x for now. How would we turn this positive 5x into 0? Or another question, 5x combined with what becomes 0? And hopefully you could say, well, I think 5x minus 5x, anything minus itself is 0. So that's going to be gone. Don't forget your equal sign. And then when we move to the right side, because we know whatever we do on one side of the equal sign we do on the other, do we subtract the 5x from the 16 or the 7x? You should say, oh, the 7x, I got it, okay. So these ones don't cancel. We'll get back to that in a sec. We have 22 equals 16, and then this is 7 of these x's, and we're taking 5 of those x's away. So how many x's do we have left? We have positive 2 x's left. Okay? Now, a couple things to notice. First, we now only have x's on one side of the equation, the right side in this case. And second, x isn't written first, so I'm going to rewrite that quickly. 22 equals 2x, and it's a positive 16. Once you only have x's on one side of the equation, now work back through SADMAP. We have a 2 that is multiplying by x, and we have a 16 that is adding. Okay? So we know we undo addition first. We're old pros at this now. Bring down that equal sign first. 16's cancel. 22 minus 16 is 6 equals 2 times x. Last but not least, we undo the multiplication with division. And 6 divided by 2 is, of course, 3. And so we get 3 equals x, or in this case, x equals 3. Now you might look at me and say, well, wait, how come you knew to cancel the 5x instead of the 7x? We definitely want to start with canceling an x. And the answer is, it actually doesn't matter. And so on 1b, I have the same equation again. Let's go ahead and cancel the 7x this time instead of the 5. And so we'd start with the positive 7x. We'd say, what cancels that? Well, we would subtract 7x. And apologize for any noise in the background. My dog has decided it's time for him to eat his breakfast 8 or so hours later, but that's all right. So we are subtracting 7x on one side, and of course we subtract it on the other. Is it from the 22? Oh no, those aren't like terms. It's got to be from the term with the x, so the 5x. There we go. 7x minus 7x cancels. Positive 5 minus 7, we're in the negative zone now. We should be a negative 2x, and then a 22. Same advice as before. Flip the order. Let's put the x's first. This is a negative 2x that we're putting first, and a positive or plus 22 equals 16. Now identify SADMAP. We have negative 2, and that is right next to x. And so if it's right next to x, then that means we have multiplication that's attaching them. And we have a 22, which is adding. Okay, let's undo our addition with subtraction. Like so. 22 minus 22 is 0. Leaves us with negative 2 times x equals, let's see, 16 minus 22. That's negative 6. And what you might notice from the other side is we didn't really have this. Negative 2x equals negative 6. We had 6 equals positive 2x. So really the only difference, depending on which x you cancel, is that if you're looking at your friend's work and you're like, how come you have all these negatives and I have positives? You might have just picked a different x to cancel. We're certainly still going to get the same answer, right? We divide off the negative 2 from each side, and that leaves us with x equals negative divided by a negative is a positive 3. Same answer, each side, nothing bad. Okay? Now, I really do suggest canceling out the x that causes your x term to stay positive. And so if you look on 1b, when we canceled out our x's became negative. And there's nothing wrong with negatives, but I find students make more mistakes if there are more negatives in the problem. So I probably would have canceled the 5 because I would have looked at both and said, oh, 7 minus 5 is positive 2x. Let's keep that there. I think that's a good way to go. So this happened in 1a instead of 1b. Either way works, though. So I have 6 problems for you to try, and then we are on to our last page. Good luck. Unpause where you need any help. Ready, set, go. All right, now you might have noticed that problems 1 and 2 are a little bit weird because they do have x's on both sides, but there's no other number on one side. So your question might be, well, wait, should I subtract 3x from each side or subtract 8x from each side? And my answer is both work. I honestly suggest subtracting 3x from both sides so that there's a number on one side and x's on the other. But I want to show you both ways to do it on the first one, and then we'll show you the one I prefer on the second one. So I'm going to split my paper in half. I'll show you the way that many students do this, and also show you where they make a mistake. So many students would start with 8x equals 3x plus 35, and they'd say, ooh, the 8x comes first. I know I can cancel a positive 8x with a negative 8x. But the biggest mistake they make is they say, okay, the 8x's cancel. I am left with, let's see, 3 minus 8, negative 5x plus 35. And then they go, okay, now there's just a negative 5 attached to x, so I'll divide off the negative 5. But do you see their mistake? Do you see what I've told you to do about 20 times so far that I didn't do here? They didn't bring down their equal sign. And it's really important to keep that equal sign there. Otherwise, you're going to, if you just tried to solve from here, well, you shouldn't actually be able to solve, you'd get the wrong answer. And so with an equal sign, to keep everything balanced, there needs to be some amount on one side and some amount on the other. But we just said the 8x is canceled. That's also, though, why I'm very careful to write zeros every time something cancels to 0 and ones when they become a 1, so that I know if I ever have a blank that I write a 0. So at this point, if we work through SADMAP, you'll notice that there are actually 2 numbers still attached to x. 35 is adding, while this negative 5, what's in between the 5 and the x, nothing, multiplying. The negative 5 is multiplying here. Turn that into a circle. So that shows us we actually have to subtract 35 from each side first. This gives us negative 35 equals negative 5 times x. And finishing it off, we divide, so same sign, by negative 5. Anything divided by itself is 1. I run out of room. X is on the right, equals in the middle. Negative by a negative is a positive. 35 divided by 5 is 7. Now again, I mentioned I would probably not do it that way. I don't like to move my x's to the same side as the number because then we just have to move the number back to the other side. And it's a little bit more efficient to do it the other way. I'm going to cancel out the x's so that all the x's are on the side without the lone number. And I'm going to do that by subtracting 3x first. First thing I do is bring down that equal sign. 8 minus 3 is 5. Don't forget your x's. 3x minus 3x cancels, and bring down your positive 35. We don't need to write the plus anymore, though. There's no number. And now, look at this. There's only one number left that's attached to x here. So we have that 5 that's right next to x, so it's still multiplication. We undo our multiplication with division. And we end up with 35 divided by 5, which is still 7. Notice on the left side I used red, purple, and blue. And on the right side I just used red and blue. So actually the right side method saved us a step as well. It also doesn't get as confusing to have to remember to write in that 0. So let's see if you can figure out the fast way to do the second one. Would you cancel out the negative 4x or the 7x? Well, knowing that we have to bring our equal sign down, we don't want to cancel the 7x because that'd leave us with 0. It'll give us some more work. Instead, I'm going to cancel the negative 4x by adding 4x to each side. These cancel. 33 equals 7x plus 4x is 11x. From here, there's only one number attached to x, and since there's no operation shown, we know it's multiplication. Let's finish that off. 11's never too bad. 33 divided by 11 is 3, and we end up with x equals 3. Now in the rest of these, there are x's and numbers on each side. So now I'm just going to bring back to my rule or suggestion guideline that I would cancel the x that makes the x's stay positive. So for example, you could think about subtracting 9x from this side. Bringing down my equals. But if you have, oh wait, there's just a weird x here. Let's put the 1 in front. There we go. If you subtract 9 from 1, that gives us a negative x. So my usual go-to is instead of making everything negative, I would probably subtract the 1x from each side first. Either step is fine. We should all still get the same answer. And if you try it a different way than I do, and you're not getting the same answer as I have, just go talk to your teacher, and that's probably a super quick mistake that they can correct for you. 8x minus 1. Ooh, don't forget the negative that's still attached to the 25. Pretty common mistake, right? We need to bring down the number and its sign. Now, if we're thinking SADMAP, there are only two numbers left that are still attached to x. There's the 8, which is multiplying, the 1 that's subtracting, and SADMAP says undo that subtraction first. Alrighty, bring down the equals sign. 8x equals negative 24. And undo your multiplication with division. X equals positive divided by, or negative divided by a positive is a negative. 24 divided by 8 is 3. Nice. Couple to go. 14x minus 8 equals 22 plus 20x. Looking at those, I think if I subtract 20 from both sides, the x's become negative. I'm going to choose to subtract 14x from each side, I think, in this case. Notice how we're doing it to the like terms. Bring down the equals. Is this a positive 8 or negative 8? Ooh, there's a negative. Actually, it's a minus at the beginning, but once the 14x is gone, now we read it as a negative. Tricky, tricky math. And then 20x minus 14x is 6x's. I always like to write my x's first, though. So I'm going to put my 6x's over here, and then take this positive 22 and write it at the end. Always nice to get in the habit of writing your x's first. Just a little tip, trick of the trade. Makes your equation solving just that much more efficient. 22 is adding. 6 is multiplying. Let's undo our addition first. Bring down the equals. Negative 8 minus 22 more is negative 30 equals 6x. And divide. Now, hopefully at this point, you're really starting to get the hang of things. You're seeing that after you cancel the x's, everything's just a two-step equation, 2 letters from SADMAP. And you should definitely be able to get these last 2 problems done. If you're still not sure after we do these last 2, you really need to talk to your teacher and get some more practice in, because we know that practice improves performance. The more you practice, the better you perform. So if you're struggling here, you should not go on to the last page until you're comfortable here, because the last page is this and more. So let's see, let's have x plus 81 equals 9x minus 7. That's pretty similar to, sorry, my screen just zoomed out. That's pretty similar to what we did previously. We had an x and a 9x, didn't we, over here? And I chose to subtract the x, and I'll do the same thing here. Always important to put the number in front, though, so we don't forget how many x's we are taking away. 1 minus 1 is 0. 81 equals 8x minus 7. I bet we could probably see that we need to add 7 first here, like so. 81 plus 7 is 88. And can you see this in your head? 8 times what is 88? I mentioned this multiplication times table was a little easier, right? We should know that 8 times 11 is 88. But if you didn't know that, you could, of course, go through divide off the 8, and you'll find on your calculator that 88 divided by 8 is 11. Last one on this second to last page. Ooh, a little trickier here. Which x do I want to undo first? I think if you add 12, that's not going to be enough to bring this negative 16 back to the positives. Just to bring negative 16 to 0, we'd have to add 16. 12 is too small. So I'm going to suggest that we actually add 16 to each side first. Adding 16 to the x's, the like terms. Bring down your equals. Those cancel. There's a 7. I'm going to write my x's first. So although you could say negative 12 plus 16, I like to think of it as 16 minus 12. That's 4x. And then this is a positive 39. Last two steps. We're going to subtract 39 from each side. That leaves us with 4x equals, let's say, 7 minus 39. You may need your calculator for this one. I think that's going to give us negative 32. And let's finish it off. Divide off the 4. And that leaves us with x equals negative 8. Okay. So these first 3 pages are absolutely the most important part of this. The last page is going to add on a couple other techniques that you've probably seen before, but these 3 are the ones you should be worried about. So definitely if you're struggling on any of these, go back to your teacher for some more help. But let's do kind of our advanced tricks at the end, and then we can get your retake done. So what we're going to do on part 4 here is we're just going to practice simplifying each side of the equation. And then we can jump to part 5 where we actually solve and simplify. Because sometimes equations can be simplified to make your overall solving easier. And there's really 2 ways to simplify. One way is distributive property. And that's where you multiply or divide, though I didn't give you any division examples here, to drop parentheses. So let's see if we can scan these problems and see if we'll have to distribute anywhere. And, oh yeah, I see parentheses, 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 parentheses. Yeah, we distribute to drop parentheses. We'll have to do that first. So in fact, why don't we go ahead and distribute, and then we'll go back to the second part of this. So distribute means take the number that's multiplying or dividing, but multiplying by the parentheses and multiply it against every term in the parentheses. So if we look at this first one, there is only one number outside the parentheses. It's the 2. So the 2 is certainly multiplying. So I'm going to multiply 2 times 12, 24. And 2 times, don't forget the sign, negative 8x. Now, although 2 times negative 8 is negative 16x, because there's a 24, we actually write this as 24 minus 16x, right? Confusing, isn't it, right? 2 times a negative is a negative, but then it becomes a minus, because they really are kind of the same thing. It's just about the context. And there were no parentheses on the other side, so I'll just rewrite. There's a 1x here minus 11x. Okay, so let's try those other 3, right? We have 9 times each of these. 9 times x, you could put the invisible 1, is going to give you 9x. 9 times positive 3 is positive 27, which we write as plus 27. Okay. Third one, we ask ourselves, what is multiplying by these parentheses? And be very careful, it's not a 4. Because this 4 is actually a negative 4. Although it is saying 16 minus 4, when you're just looking at the 4 by itself, this minus becomes a negative, and we have negative 4 times each of these. So I'm going to rewrite everything that's not changing. Okay, there's still a 16, and now we'll work that negative 4. Negative 4 times 1v is negative 4v, but because there's a 16, it's minus 4v. And negative 4 times positive 7 is negative 28, but because there's a term in front, minus 28. Last but not least, there's a positive 8 multiplying. So bring down the 3t. That's not going to change. The 2 and the 14, let's change the order. 14t plus 2. Good practice to put your variable first. Now we multiply. 8 times 2 is 16. It's positive. And 8 times negative 6 is negative 48, so we write it as minus 48. So that's really all we tend to deal with for parentheses this semester. And with parentheses, we just drop them with distributive property. Nothing too terrible. So in SADMAP, we do actually want to get rid of those parentheses first, even though SADMAP is at the end. There's a few exceptions, but we won't talk about those for a while. But there is one more thing that you probably should do when you simplify these equations, and that's combine like terms. Now, both of these properties, distributive property and combining like terms, only work on one side of the equal sign at a time. You should think of that equal sign as a barrier or a force field. And the only way you can do things to both sides is using algebra. For now, we're just focusing on the same side. So we'd ask ourselves, is there anything that we can combine between 24 and negative 16x? No, those are not like terms. I'll put the negative 16x first and the positive 24 second, and then bring down your equals. And then we say, okay, well, we did that. Now, is there anything we can combine between the 1x and the negative 11x? And yeah, those are like terms. So we have 1 and a negative 11. And so although it's 1 and negative 11, when you combine them together, we just do 1x minus 11x. You do what the sign tells you that's in front. Okay? 1 minus 11 is negative 10x. And now we've simplified. On our second one, let's take a look. 9x and 27 are not like terms, so we can't do anything there. 4x minus 3, those are not like terms either. That's as simplified as we get. And then you'd start solving like we did on the last page. The third problem, 2v plus 18, not like terms. What about this right side? 16 minus 4v minus 28. Ooh, I see two like terms there. So I'm going to go ahead and rewrite my left side and the equals. Which terms are like terms, though? Ooh, well, I think the positive 16 and the negative 28 are like terms. And we just read straight through. Positive 16 minus 28, well, that is negative 12. So I'll put the negative 12 here. Negative 4v didn't change at all. I tried to turn it into a y, though. Negative 4v is here, and this negative 12, we now, because there's another number here, write it as a minus 12. And that's as simplified as possible. Last one. Okay, nothing to combine on the right side, but I think on the left side we'll find some like terms. Oh yeah, look at this. We have a positive 3t and a positive 16t. 3 plus 16 is 19t, and then of course minus 48. So at this point, we've really learned every trick we need. We've seen that if we have parentheses or like terms, we should simplify. We've seen how to solve variables on both sides, two-step equations. So I just have 6 problems left for you guys to try. And once you finish solving them, we will come back together, see how you did, and you are done with your remediation. And I apologize for this video being pretty long, but remember, it's trying to go back over 5 classes worth of material, 5 75-minute videos condensed into one. So hopefully you really did skim through to just get to the ones you needed help with. All right, so pause me, try these 6, and we'll see how you did. Good luck, and unpause when you're ready. Okay, so I'm going to give you a set of 3 directions that I always suggest you look at. The first thing you're going to look at is you want to make sure that you try distributive property first. We want to drop those parentheses right away. And so I'm actually going to go through and do all 6 of them really at the same time, just so we can focus on distributive property first. And maybe I'll do all that in green. So our first problem here, we need to distribute the 2. 2x, and 2 times negative 3 is negative 6, but we write it as a minus 6, equals 10. Okay. Second one, I see distributive property as well, this positive 3. The negative 4 isn't changing, neither is the 11. That gives us positive 6. Positive times a negative is a negative 3x. Sometimes students will ask, where's the x on our calculator? And honestly, most calculators don't have an x button that's useful for you. So instead, if you want to see how to do this positive 3 times negative x, just multiply the numbers. On your calculator, do positive 3 times negative 1, that's negative 3, and just bring the x along, and that's where we get this. Okay. Third one, I see lots of parentheses. Let's multiply the 3. 6x minus 3, and then, parentheses, but there's no number? What number is always being multiplied if it's not written? Oh, right, that's a 1. And in fact, in this case, it's not even just 1, it's a negative 1. Watch those signs. Negative 1x, negative times a negative is a positive, and 1 times 4 is 4. Fourth one, no parentheses, that's exciting. Fifth one set of parentheses, they go pretty quickly though. Positive 8 times 2x is 16x. 8 times negative 6 is negative 48. Don't forget to bring down the rest though. 3x, it's a positive 16x, so we write it as a plus. And I'll put my x's first. Last one, 2 sets of parentheses. We distribute the 12. That's 36 plus 12x. And we distribute the 5. Almost forgot my equal sign. 10x plus 40. All right, so we've done all of our distributive property. The second thing we want to try is what we learned up above as well. We want to try and combine like terms, and I'll try to do this one in purple again. So when we combine like terms, we only look at one side at a time. On the first one, no like terms. No like terms. That's easy. Second one, certainly no like terms with the 11. But I think when you see 3 terms over here, 2 of them are like each other. So I'll bring down the 11. Don't forget your equals. And my like terms here seem to be negative 4 plus 6. Or read it backwards. 6 minus 4 is 2. I like to write my x's first, so negative 3x won't change. But if 6 minus 4 is positive 2, I'll put a plus 2 at the end. All right, third one. There are certainly no like terms with the 9, it's by itself, but there are definitely like terms on this left side. 4 terms, I think there are 2 sets of like terms. We have, I'll start with the x's, 6x minus 1x. 6 of something minus 1 of something is 5 of those x's. And negative 3 plus 4, I like the positive first. 4 minus 3 is positive 1. All right, moving on through. Let's see, any like terms here? There are no like terms with the 3x minus 5. There are like terms on the left side. We have 3x plus 1x. That's 4 x's. And the minus 1 didn't do anything, so it tags along. Fifth one. No like terms on the right side. That's nice. But the left side, we do have them. 3x and 16, positive 16x is 19x's. Writing those first, and the minus 48 after. Last one. No like terms on the left side, no like terms on the right. Nice. Okay, next up, we really start to solve. Now there's 2 types of equations that we have left. We have equations that only have x on one side, like problem 1, like problem 2, like problem 3. But then 4, 5, and 6 have x's on both sides. So I'll go back through and do 4, 5, and 6 after. So let's do 1, 2, 3 first. They're all nice, simple 2-step equations. Thinking through SADMAP on the first one and then running through the rest. We undo addition or subtraction first. That's the 6 on each side. Bring down your equals. That leaves us with 2x equals 16. And I would hope you could tell me 2 times what is 16, but in case you're struggling a bit, just divide off that 2. Your calculator will do the work and give you x is 8. The second problem, pretty similar. I see 2 numbers attached to x. We undo the addition and subtraction first. I'll subtract the 2 from the same side of x and from the other side because of algebra. That leaves me with negative 3x equals 9. And then we undo the negative 3 that is multiplying by x. Anything by itself is 1. Positive divided by a negative is a negative. 9 over 3 is 3. Third one. 5x plus 1 is 9. I'm thinking that I'm not going to get a nice answer here, but that's okay. Maybe it's possible I made a mistake, and you could definitely tell me on the video, but let's go through it. Right? We're going to undo adding 1 by subtracting 1 from each side. Yeah, my guess is I made a mistake with the sign when I was typing this problem. Whoops. Oh well. Bring down our equals. 5x equals 9 minus 1 is 8. And then to finish this off, we might need our calculator here. We're going to divide both sides by the 5. Now the reason I knew I might have made a mistake is I tried to make most of your answers come out to be pretty nice integer answers. I think this one will be a fraction. $8 divided amongst 5 people. Not everyone gets the same amount. So you can actually leave it as that fraction, 8 over 5. That's fine. You could say that it is 1 3/5 if you're comfortable with fractions. Or if you try this on your calculator, then you're going to end up getting 1.6 exactly. Perfect. 3 to go, and we are done. Finally. Now these last 3 have x's on both sides, and if they have x's on both sides, then we're going to go through and cancel those x's first. We can cancel the 4x or the 3x. I think I'll probably cancel the 3x on each side first, like so. That way we'll keep our x's positive. 4x minus 3x is 1x. Don't forget your equal sign. Minus 1 equals, negative 5. Okay. Then we look at the side that has x. My side that has x is here. We're going to undo subtracting 1 by adding 1 on each side. And notice that this is a 1x, but to undo a 1x, we don't even need to write the 1, do we? I think we're actually done on this side. It's just x equals negative 4. 2 problems to go. Great job, guys. We can either undo the 19x or the 14x. I think undoing the 14x from each side is a good way to go because that will keep our x's positive. Okay. 19x minus 14x is 5x minus 48, and that equals 2. And we have 2 things to undo here. We undo the addition and subtraction first, adding 48 to each side. Don't forget to bring down that equal sign. That leaves me with 5x equals 50. When I've run out of room here, I'm going to use my trick and use the second column over here. 5 times x equals 50. I bet you could tell me 5 times what is 50, but if you're not sure, just divide by 5. And 50 divided by 5 is 10. Last problem. Sigh of relief because you know how to do these by now. Let's undo our x's first. We could either undo the 12 or the 10. I think 10 makes more sense because that will keep all of our x's positive. And again, it doesn't really matter. You'll get the same answer. I'm just trying to lend some expertise. I've been doing this for quite some time now. So let's see. 12 minus 10 is 2 x's, and I'll write that first. 2 x's. Don't forget your positive 36. And on the right side, we have a positive 40. SADMAP says undo the addition first with subtraction. Bring down that equals. 2x equals 40 minus 36 is 4. And let's just cheat a little bit. 2 times what is 4? 2 times 2 is 4. All right, so I apologize for how long this video ended up being, but I really wanted to do justice to how to solve all these types of problems. But at this point, you are now ready to see your teacher to retake this goal of solving equations. So we had all these different pieces. You should expect all of these to be on your retake, but not that many problems, right? There might be one problem from this part of part 1, one problem here, that's 2, 3, and then 4, and maybe 5. So maybe 5 or 6 questions should be good. But again, we need to do this extra practice so it cements itself in your brain. Practice improves performance. If anything in this video didn't make sense or you need more practice, just go see your teacher. They would be happy to work with you. Thank you so much for tuning in, and I wish you best of luck in algebra.